Hi, welcome to the video. So we're looking at a probability situation here where a coach is selecting 10 golfers for the middle school golf team out of 3 6th graders, 3 7th graders, and 4 8th graders. And we're asked to calculate the probability, she's selecting 2 captains. So we're asked to calculate the probability that both of the captains chosen will be 8th graders. In order to do this, there's an underlying assumption, and here it is explicitly said, that she's going to randomly select 2 captains, which is interesting, but that's an assumption of the problem, so that's helpful to solve it, right? Randomly selecting them. If she wasn't going to randomly select them, we really couldn't come up with a scientific probability here because we don't know the other criteria she's using. So she's going to be randomly selecting 2 students to be captains, and we want to know the probability that both of them are 8th graders. So we see that word both, so we're thinking about an and probability. So let's start writing things out. The probability that both are 8th graders, just write it that way, probably both are 8th graders. We can think about it as the probability that the first one chosen is an 8th grader, so the first is an 8th grader, and the second is an 8th grader. Now, when we're dealing with an and probability, if the events are independent, we love to break it up into 2 separate probabilities and multiply. Here, however, we can't assume the events are independent. Even though she's choosing randomly, we can think about, if we know that she chose an 8th grader for her first captain, does that change the probability that she'll choose another 8th grader for the second? And it does, because once we know that an 8th grader has been chosen for the first captain, there's no longer 4 8th graders left to choose. There are now only 3 8th graders left to choose from. So we're going to need to break this up into a conditional probability. So how we can rewrite this, let me get some space over here, we're going to rewrite this. The probability of choosing both an 8th grader first and second will be the probability of choosing an 8th grader first, so the first one's chosen is an 8th grader, times the probability that the second one is an 8th grader, given that the first was an 8th grader. So now let's work on each of those and figure them out. So to find the probability that the first is an 8th grader, well, when the first student is drawn, we can think about how many of 8th graders, so the number of 8th graders, divided by the total number of students. And we're told in the story, before anyone's chosen, there are 4 8th graders and 10 students total. So that first number in our calculation is the fraction 4/10. Now we're going to look at the second number in the calculation. How do we come up with this conditional probability? So we'll zero in on this. The probability the second student chosen is an 8th grader, given that the first is an 8th grader. So now we know that for sure one student has already been chosen and they were an 8th grader. So the total number of students left for us to choose from is no longer 10, because one of them already got picked. We can't pick the same student to be captain twice, so when we're making that second draw, there are now only 9 golfers left to choose from. So our denominator will now be 9. And our numerator, how many 8th graders are there now left to choose from? Well, we know we got an 8th grader on our first pick. So there's no longer 4 8th graders left to pick. There's 3. So this fraction will be 3 out of 9. So we can think about this as the number of 8th graders left divided by the number of students left when we get to that second pick. So if we scroll down to give ourselves some room to show the rest of the calculation, as we calculate the rest of that out there, it's 4/10 times 3 9ths. If we multiply across, we get 12 90ths, which is a nice answer, but notice WAMAP is asking for the answer as a reduced fraction. So we have to look at that and say, did they have any factors in common? Sure, we could divide them both by 2. We can also divide them both by 3. We can go even more quickly and divide them both by 6. I divide by 6, 12 divided by 6 gives me 2. 90 divided by 6 gives me 15. So the answer I'm getting here would be 2 15ths. So if she chooses the 2 captains at random, the probability that both will be 8th graders is 2 out of 15.